All right, let's take a look at Unit 7, Lesson 10, Estimating Proportions from Samples. So we're going to estimate population proportions using data. All right, so for 10.1, proportions, mentally evaluate the proportion of chips that are blue. All right, so 17 are blue out of 50 chips, and then 28 are blue out of 50 chips, 17 are blue out of 20 chips, and 21 are blue out of 60 chips. So go ahead and think about these and figure out what those proportions are. All right, so for the first one, if 17 out of 50 are blue, then that means it's the same as 34 out of 100. Just multiply each of them by 2. And so that would be 0.34. 28 out of 50, again, would be the same thing as 56 out of 100. So that would be 0.56. 17 are blue out of 20. So that would be the same thing as 85 out of 100 if you just multiply both by 5. Again, this one we're multiplying by 2, multiply by 2. And then for here, we're multiplying by 5. So that was 85 out of the 100, so 0.85. And then you could also divide by 2. So then it's 8.5 out of 10. That's another way of looking at it. And then 21 are blue out of 60. If you divide both of those by 3, divide by 3, that's the same thing as 7 out of 20. Right? 7 out of 20. And so then if you multiply that by 5, you get 35, so 0.35. Or if you divide by 2, you get 3.5 out of 10, which is the same thing as 0.35. So again, there are multiple ways that you could figure that out and do that mentally. All right, 10.2 we are not going to do. So we will just move along to 10.3. 10.3, fly memory. A biologist is breeding fruit flies to include a specific genetic mutation that will be useful in understanding memory in humans. To check whether a fly has the mutation, a DNA sequence is analyzed in a way that kills the fly, so the biologist only wants to sample or to test a sample of the flies to estimate the proportion of flies that have the mutation. The biologist selects 40 flies to sequence at random and finds that 9 of them have the genetic mutation. So based on this sample, estimate the proportion of flies in this group that has the genetic mutation, right? And so again, they found that 9 of them have the genetic mutation, and that was out of 40, right? And so let's bring up a calculator to help us out here. There we go. And let's clear that. So we had 9 out of 40, which is 0.225 or 22.5%. All right, the scientist is worried that only having one sample may not be reliable for estimating the proportion of flies with the mutation, but does not want to sacrifice more flies to get a larger sample. The proportion from the sample is a good estimate for the population proportion, but it is difficult to understand the possible variability from a single value. So Andre has a suggestion for how to better understand the variability. Assume the sample is representative of the population of flies and create a simulation that mimics what the scientist found. Andre gets 200 pieces of paper and marks 45 of them as mutant, right? And puts them all in a bag. So since Andre decides to use 200 pieces of paper, why should 45 of them be marked mutant? Right? 45. Why should 45? And remember, it was 9 out of the 40 that were mutant, right? So he wants 45 of them to be marked because if your sample is 200, well, 4 times 5 is 200. So then 9 times 5 is your 45. So the overall proportion is still the same. So some other combinations of total numbers of pieces of paper and number marked mutant. You could do any multiple of 9 and 40. For example, if you multiplied 9 by 2, you could have 18 out of 80. You could multiply by 10 and you could do 90 out of 400, right? So there are lots of different combinations as long as it's still that proportion of 0.225 or 9 out of 40. All right, Andre then simulates the scientist's sample by drawing a slip of paper from the bag, noting whether it is mutant or not, then replacing the paper into the bag and drawing another paper until he has a sample of 40. He repeats this process for 50 trials and creates a dot plot showing the proportion that are mutant from each trial. Estimate values on the dot plot a range of proportions that include about 95% of the proportions from the trials. So what values on the dot plot or on the dot are a range of proportions that include about 95%. Remember that 95%, well, let's see, we have 50 trials. So 95% of the trials would include about 43 of them. And so we are looking at about from 0.1 to about 0.3 in between those. That would be about 95% because you have 1, 2, 3, 4 left over there. So that would be out of 50, that'd be about 92%. So that's pretty close. Okay. Andre then finds the mean proportion from his simulations to be 0.2195 and the standard deviation to be 0.6. How far are your values from the last question from the mean? All right. So the mean is 0.2195. And if we subtract 0.1, we get 0.12. And that's 2 standard deviations away. And if we do 3 minus 0.2195, oh, sorry, that was 0.3. We get, oh, that was about, right? We get about 0.08, which is not quite 1 standard deviation away. And again, 0.2195 minus 0.1 is about 0.12. So we have 1 standard deviation to the right and 2 standard deviations to the left. So that's pretty close to about 95%. Okay. All right, and then we're going to divide the distance from the last question by the standard deviation to get the margin of error in terms of the number of standard deviations. All right, so 2 standard deviations for this one, again, because that was 0.12 and the standard deviation was 0.06, and so that's 2 standard deviations. That upper limit, though, that 0.3 would be 0.08 divided by 0.06, and so 0.06, oh no, not 6, 0.06, and so that's about 1.3 standard deviations away. So not quite 2. All right, based on Andre's simulations, should the scientists feel confident that the proportion of flies is within 2 standard deviations of the mean? And I would say yes, because the first one was pretty spot on with 2 standard deviations, while the second one is more than 1 standard deviation away, but not quite 2. So the scientists should feel pretty confident, because the estimates were within about 2 standard deviations. That's a D. All right, we're not going to worry about are you ready for more, and if you want to take a look at the summary, you can do that.